So what I'm going to talk about today is all the new features that we've had over the last 2 years in Java. And what we've seen is clearly a shift away from the older, longer time between releases where we were waiting anything between, about 2 and a bit years up to 4.5 years between major releases. And now we have a release every 6 months. So I've updated the title from this because, of course, literally last week we got JDK 13. So now we have from JDK 9 to 13 and beyond. So let's start and go back a couple of months, or a couple of years, in fact, to JDK 9. JDK 9 was very significant as a release for Java because Oracle said that this was going to be the last major release of Java. And what they meant by that was the last release that had multiple years of development work behind it. And again, as I've said, we've shifted to the idea of only 6 months between releases now. And so this slide shows all of the new features that were included in JDK 9. I think there are about 86 or so that I counted up. And I borrowed the slide from Oracle because I used to work for Oracle, so I figured they still owe me a few slides. And like I say, there's lots of features in there. Some of them very small, 1 or 2 of them slightly bigger. And of course, the one in JDK 9 that was really significant was modularity. So I just want to spend a couple of minutes talking about this. Clearly, we've kind of moved on a bit from modularity, but it's still something that's very relevant to us as developers. And in terms of kind of making that clear, let's just have a quick show of hands here. So who here is using JDK 8? Right. Who is using JDK 11? Okay, see, that's good. That's good sort of number. What I'm seeing is there is more of a shift to using JDK 11. But that jump from JDK 8 to JDK 11 is a bit more significant because of modularity. So like I said, I'll just spend a couple of minutes talking a little bit about this. So modularity was really about 2 things. The first of those things was, in my opinion, a very good thing. Because if you look at the history of Java, you go right back to JDK 1.0. I'm old enough to remember that. And you look at the libraries you had there. There were 211 public classes that you could use to develop Java applications. If you wind forward to JDK 8, rt.jar contains about 4,500 public classes that you can use to develop applications. And this is very good because now we don't have to write a semaphore class. Now we don't have to write an array list class. All of these things are provided for us. So this is great. However, the problem is that those 4,500 classes are all in one file. Now, that just doesn't make any sense because if you think about it, and I constantly try to challenge people on this one, is to think of an application that could use all 4,500 of those classes. It really would be something to try and do an application that did that. So it doesn't make sense to have them all in one file. Modularity was about breaking that up into more manageable chunks so that we could build runtimes specific to an application. And what they came up with is, if you look at the OpenJDK, there are 75 modules. 24 of those are for Java SE, which is the core part of Java, what you need in order to call something Java because it conforms to the specification. There are 2 aggregator modules in there. And an aggregator module is one that doesn't refer to packages, but only refers to other modules. And then, bizarrely, there's the smart card module, which kind of got just put in there ages ago, and nobody seemed to notice, and it just ended up there. And then there's 48, which are JDK specific, that cover all sorts of different things to do with tooling and so on. If you look at the Oracle JDK, at least in JDK up to JDK 9 and 10, there are another 14 additional JDK ones. There's 8 for JavaFX, and there's a couple of Oracle-specific ones as well. So this is all very good, the fact that we've divided up rt.jar into more manageable chunks. The other half of modularity that Oracle wanted to do was encapsulate internal APIs. because if you look at the rt.jar file, there's these 4,500 public classes, but then there's a whole set of classes that are there to make those classes work. And they're ones that you're not supposed to use. You know, Sun and Oracle have always been very explicit about this, in the sense that they don't document them, they don't tell you about them, only in the sense that don't use them. And the most famous or infamous of those is Sun Misc Unsafe. I really like Sun Misc Unsafe. The reason being the clue is in the name, unsafe. Don't use it. So, who here has used Sun Misc Unsafe in their code? One person. Okay, that's really good. So this is good. Who here has used a third-party library or framework like Spring or Hibernate, Log4j, anything? Yes, there you go. And you've used Sun Misc Unsafe. You just don't know about it. But what Oracle wanted to do was to essentially turn off access to all of these internal APIs. And that really wasn't going to work, because with things like Spring using it, then it became an issue where it couldn't just be turned off without massively breaking backwards compatibility. So what they did was they allowed you to use modularity, to use the internal APIs with some additional command line flags. Now, the big benefit of modularity is, as I kind of mentioned earlier on, the ability to build a runtime that's specific to your application. And they provided a tool called jlink. So jlink says, okay, build me a runtime for my application. And if we look at the example here, I created a small sample application. And here what I'm doing is I'm saying, okay, jlink that, say where the modules are located, the module path, then the module that I actually want to build the runtime for, in this case it's com azul zap, and then a directory where I want the output to go. If I go into that directory, I'll find what looks like the JDK. It has a bin directory, a conf directory, a lib directory, and so on. And if we go into the bin directory there and run Java with the list modules flag, I'll see all the modules that are included. So I've got base, Java logging, SQL, XML, then I've got my own application modules, Zap, Zoop, and Zeta. The great thing about this is you can take a full JDK that's about 340, 350 megabytes, and in the absolute smallest case, you can reduce it down to pretty much less than 10 megabytes. Obviously, that's for the sort of hello world type application. Once you start building anything that's more complex, it'll start growing in size. But it really can reduce dramatically the amount of space that you require for the runtime. When you're dealing with things like microservices, this is ideal because you can deploy your runtime into a container specific to the service that you're delivering, and then you can reduce the size of the container that you're building. So this is a really good idea. Now, JDK 9 also had a number of other things that were quite significant about it. And the first of those was the approach to compatibility. And this is a quote from Oracle's product management. They say, clean applications that just depend on Java SE should just work. Well, that's a little less than reassuring. What I'd like to see is will just work. But no, they should just work. And there are a number of reasons for this statement being true. And that is because one of the things Oracle did with JDK 9, as well as modularity, was they started a cleanup. And this is something that was long overdue with the JDK itself. By the time JDK 9 was released, Java was, sort of 22-ish years old. And lots of features had been added to the JDK over those 22 years, but literally none of them had ever been removed. And this had led to a massive accumulation of technical debt that Oracle were having to deal with. They were having to support a number of things that either very few people used or even nobody used. And when you're dealing with security issues, when you're dealing with stability, it's a lot of work to keep these things up to date when there's literally only a handful of people using them. So we finally saw some deprecated APIs removed. Again, 22 years we've had deprecation, nothing removed. Kind of defeats the object of having deprecation. But now in JDK 9, they started. Not in a big way. They removed 6 methods. That's it, 6 methods. And so you look at that and you go, hang on, 6 methods. What did those 6 methods do that was so bad that meant they got removed and everything else got left behind? And the answer to that one is that when they came to divide up the rt.jar into modules, they found some very odd relationships between bits of code. And so eventually they sort of decided that in order to make a clean separation of modules, there were these 6 methods that they could remove, and then that just kind of tidied things up. There was one other class, but that was part of the Java authentication and authorization service, which is not part of the Java standard. And then JDK 10, they also started doing a little bit more, and they removed a whole package, 6 classes, 9 methods, and a field. And they also started removing redundant features, things like the JHAT tool, the JVM tools interface, hprof agent, that went away. A number of obscure garbage collection combinations also got removed. And this has continued, JDK 10, JDK 11, JDK 12. They're gradually removing little bits and pieces over time. And the most important thing is that this is going to continue in the future. We need to be aware of this as Java developers. So, for example, the CMS garbage collector, concurrent mark sweep, that has been deprecated, which means at some point in the probably not too distant future, it will be removed from the JDK. I know there are a number of people who are kind of a bit opposed to that because they say that CMS gives better performance in some situations than G1, but Oracle only want to maintain one collector like that, so G1 is the choice. Nashorn, Pack 200, those have been deprecated as well, so they will be disappearing at some time in the future as well. And we may well see others. I mean, if I just kind of throw it out there, who knows? Things like AWT may get deprecated. Not saying it will, but that's something that might get deprecated. So the key thing here is that compatibility for Java is no longer guaranteed. Oracle have said that, and they have been quite clear about this. They've said new versions of Java may include breaking changes, but they will give us some warning. They will deprecate anything that they intend to remove in the future, and they very generously told us that they will give us a minimum of 1 release warning about deprecating and removing a feature, which is kind of good of them because anything less than 1 release warning would be no warning at all. So the important thing there is it could be only 6 months between a feature being deprecated and a feature being removed from the JDK. So be aware of that when you're thinking about migrating applications and keeping up with this faster release cadence. Okay, so that was JDK 9. What did we get in JDK 10? Now, JDK 10 was only 6 months later, so there wasn't a huge amount of development time and not a huge number of new features. The biggest thing in JDK 10 was the introduction of local variable type inference. So Java now gets var. Great, maybe. And so there's a couple of simple examples here. What we're doing is we're saying, okay, rather than having to specify explicitly the type of a local variable and then assign an instance to it, where you effectively duplicate information, because let's face it, if we said user list is an array list of type string, then we'd have to say array list of type string user list equals new array list, and then we could use the diamond operator to at least avoid the second generic type parameter. But you're saying array list twice in the same line. It's just not really necessary. So now you can use var, and the compiler can say, okay, I will infer that because you're assigning a new array list of type string to that variable, very obviously, the variable itself is going to be an array list of type string. Similarly, if we use the stream method on that and retrieve a stream from there, the compiler can infer, because we've got a collection of strings, that the stream will be a stream of type string as well. We can use var in loops. So if we want to, we could use the more modern for each style of for loop syntax, and we can say for var name over user list, and that will infer string. And then, actually I've got a typo in this slide still, but in this case we could say for I equals 0, imagine that's there, I less than 10, I++. Now, in this case, this is a bad use of var. The reason I say that is because var has 3 letters. Int has 3 letters. So you're not saving anything in terms of typing, either typing on the keyboard or typing in terms of the what your variable is. So in that case, probably not a good idea to use var there. One thing that var is good for as well is cleaning up code. So here's, I've created a sort of fairly extreme example of a try with resources block. And so what I'm doing is I'm saying, okay, I want to create an input stream, then I'm going to create an input stream reader, then I'm going to create a buffered reader. And clearly there's massive duplication of types and names in here, which makes it very verbose, quite difficult to see what's going on. If we use var in this case, then we can say, okay, var input stream reader, var buffered reader. And suddenly it becomes a little clearer, a little easier to see what's going on, eliminates some of that duplication. So var is a good thing for improving the readability of your code, but be careful with it, because there are many cases where it's not necessarily a good idea, because sometimes it actually makes it harder for somebody reading your code to understand what the type of that variable is. Important thing about var is it is a reserved type, not a reserved keyword. What does that mean? Well, it means if we had var as a reserved keyword, we could no longer use var as a variable name, which would be very bad, because I'm sure that most people here at some point have used var as a variable name. So in this case, what we can do is we can say var equals new value added reseller. That is still quite legitimate code. What you can't do in JDK 10 that you could have done in JDK 9, but you never would have done, nope, definitely wouldn't have done this, is create a class called var with a lowercase v. So you wouldn't have done that in JDK 9 or 8, but now you can't do it in JDK 10. Of course, you can still create a class called var with an uppercase v. So this is the implication of it being a reserved type, not a reserved keyword. In terms of JDK 10, there were a number of what are called JEPs, JDK enhancement proposals, that were included. And I haven't listed all of them here. I've just listed a few which I think are sort of worth spending a couple of moments talking about. One of those was the introduction of a parallel full GC in G1. People had complained about the performance of G1 compared to the parallel collector, and there is the full compacting phase of G1 used to be serial in the sense of only using a single thread. What they did in JDK 10 was to divide that up so that they could use multiple threads and make it parallel, and therefore get better performance from that. JEP 3.10, this application class data sharing, is or was a commercial feature in the Oracle JDK. It was open sourced, and then you can use it within the OpenJDK. The idea behind this is that when you start an application, the JVM has to load the class files that you need to run your application. So it loads the class files, builds some internal data structures to represent those class files, and then runs the application. When you restart the application, it does exactly the same thing again. So it reads the class files, builds the internal data structures, and off it goes. Application class data sharing says when you start your application and the internal data structures have been built, they get written to a file. Then when you start it up again, the JVM, rather than having to do all of the work the same as it did before, it simply maps that file into memory, points its data structures at that memory mapped area, and it's ready to run. So it reduces the amount of time that's taken to get an application to start up. The other advantage is that if you're running multiple JVMs on the same physical machine with the same application, then because it's memory mapped, you can share that amongst the JVMs because it's read-only data, and you can reduce the amount of resources that are required for those JVMs. JDK 10 introduced an experimental Java-based JIT compiler called Graal. Now, this is not to be confused with Graal VM, which is another project which, for some bizarre reason, Oracle decided to call the same thing as the JIT compiler in the OpenJDK. Primarily, I think, to confuse everybody. But Graal, the JIT compiler, is a JIT compiler that's written in Java, and is designed to try and optimize more heavily the code that gets generated for code that you're actually running on your application. So it's about improving the performance of your application. And then the last one there is JEP 316, which is heap allocation on alternative devices. This is some work that was contributed by Intel. Intel have been developing non-volatile RAM that runs at the same speed pretty much as dynamic RAM. Their idea was to allow you to put your heap onto non-volatile RAM or dynamic RAM, and if you wanted to, you could run it on non-volatile RAM and then be able to restart your application still with the same heap. So there's some work going on there, which is quite interesting. JDK 10 had some new APIs. There are actually 73 new APIs. I'm not listing them all out here, but there are a few that were worth sort of discussing. Several of the APIs are around the idea of unmodifiable collections. So list, set, and map interfaces now have a new static method on them called copy of. That takes a collection and returns an unmodifiable copy of that collection in the form of a list, set, or a map. Similarly, for the streams API, there are now 3 new collectors, which will allow you to take a stream and collect them into an unmodifiable list, map, or set. There is a new method on optional called or else throw, which does exactly the same as get, just requires more letters. Again, it's one of those things where you sort of think, why did they bother? Somebody did kind of try to explain it to me in the sense that it's more descriptive about what it does. Okay, I'm not going to pass comment on that. Okay, JDK 11. So this is the current long-term support release and came out about a year ago, actually, yes. So what did we get there? Well, the first thing, and probably the most significant in some ways, was the extension of how we can use local variable syntax for type inference. What the developers of Java did was say, okay, let's extend where we can use local variable type inference to lambda parameters. So here's an example of lambda expression. So I've got a map and I'm mapping to lowercase. Okay, that's all good. But the interesting thing here is that one of the big design decisions and the work that they did on lambda expression was to include type inference. So in this, we don't explicitly have to state the type of S as being a string because the compiler can infer it for us. So that's all good. So with local variable type inference, we can now do this. We can say var S, S to lowercase. And you look at that and you go, why? Why would I possibly want to do that? It makes no sense. I'm simply adding text for the sake of adding text. And the answer is there is one and only one situation where you would possibly want to do that. And that's if you're going to use an annotation. In this case, in order to use an annotation, you can't annotate with just the variable name. You have to have something in there which indicates the type of that variable in order for the syntax to work correctly. So in this case, we can use @ not null, and then we could either explicitly state the type of string, or we can use var and let the compiler fill in the bits for us, and then say yes. So there's one sort of corner case where you might want to use the local variable type inference on a lambda expression. Another thing that was introduced in JDK 11 was the idea of being able to launch a single source file. And the idea behind this was to simplify how to get started with Java. There's always been this issue about when you want to write your first program in Java, it's actually quite difficult. Because if you think about it, in order to just print hello, what do you need to do? Well, you need to edit a Java file, then you need to say public class hello, then you've got public static void main, string brackets args, system.out.println, hello, and then lots of brackets and things like that. Then you've got to compile it, Java-C, then you've got to run it with Java. So there's a lot of ceremony involved in just getting Java to print hello. In terms of JDK 11, if you look back at how things worked before, there were 3 ways that you could launch a Java application. The first was simply using the class path. So you say, Java hello, and that runs whatever the hello class is, on the class file, or you could do it directly from a jar file. You do java -jar hello.jar, that would work. And because we now have the module system, you can also do it from the module path, and you can say java -m hello, and that would run it from the module path. In JDK 11, there is a fourth way. So now you can actually run an application declared in a single source file. And that's quite important, is only a single source file. So in this case, you can just do java factorial.java 4. The Java runtime will look at that and go, factorial.java is not a class, it is a Java source file. And at that point, it will say, I will save you the effort, I will run javac on that, generate a class file for it, and then execute the class file through the JVM, passing the parameter 4 to the executable. There is another way of doing that, where we can go one step further and we can use Shebang support. So if we create our source file and we make the first line #bang, and then we say where the Java executable is, Java home bin Java, and we specify the source level we want, which is 11, and we make that source file executable, then we can just do /factorial4. The runtime system, assuming we're using Linux in this case, the runtime system will say, okay, run Java on that, that will compile it, and that will then run it and give us the result that we see printed out. So it's just a sort of simplification. It only works with a single source file, but you can obviously specify things on the class path, and you can add jar files and all sorts of things like that. A few more selected JEPs for JDK 11. First of those was JEP 181, Nest-Based Access Control. Now, this is part of a bigger project called Valhalla, and I'm going to talk a little bit more about that towards the end, which is to do with value types in Java. And one of the things that they needed to do in order to make that work was to change some of the way that nested classes work. So you have inner classes in Java. And if you look at how inner classes work in terms of the access you have to private variables in the outer class, nest-based access control simplifies from the JVM's perspective how it gets access to those variables in the surrounding class. Dynamic class file constants. I always look at this and I go, hang on, how can a constant be dynamic? It's either dynamic or it's constant. Can't be both. But what this is about is making life easier for people who write compilers and languages that they want to compile into bytecodes. Because not all languages are the same, as we know. So again, if you go back to sort of JDK 7, the introduction of invoked dynamic bytecode, that was about making life easier for people who were creating compilers for languages that are dynamically typed to run on top of the JVM, which is designed for a statically typed language. Dynamic class file constants is another approach to make life easier for compiler developers. And essentially, you can think of this as a class file has constants involved in it. And what this allows you to do is treat those constants as if they're like a final variable in Java. So a final variable is one that you can set the value once and then it is fixed. So this is why you get dynamic constants. So the constant is set once when you run the application, but then it is fixed. So it's that sort of approach. And there are certain situations where that is very useful for certain languages and the way that they work. JEP 318, the epsilon garbage collector. This is an interesting approach to garbage collection because it doesn't collect any garbage. So you think, okay, what's the point of a garbage collector that doesn't collect any garbage? And realistically, there's two things you can say about that. The first is the real reason that it was added, and this came from Alexei Shipilev at Red Hat, who is also developing the Shenandoah garbage collector. The real reason for the epsilon garbage collector is to enable people to test the efficiency of a garbage collection algorithm. So what you do is you run your application with the epsilon garbage collector, so no garbage collection happens, and you monitor the performance level of your application, see how it works, assuming it doesn't run out of heap. And then you switch on your garbage collector and you run the same application, run the same benchmark, and then you look at the difference between the two results, and that shows you how much impact your garbage collector is having on your application. The second idea that people think is very good for the Epsilon garbage collector is things where you've got serverless, the terribly named serverless computing, or AWS lambdas. This idea of effectively stateless functions that you execute very short-lived type things. So if you've got a very short-lived thing, chances are you may not need to do garbage collection, so using the Epsilon GC could work well in that situation. Your mileage may vary. 3.2.1, HTTP client, that was really just taking the code that was introduced in JDK 9 as a sort of, it was a preview module, which was put there so that HTTP2 support could be added, but the approach to the way that the API was designed could be open to change. So people could provide feedback if they wanted to change things. In JDK 11, that's now being made part of the standard. JEP 3.3.2, adding transport layer security version 1.3. That's really just bringing things up to date in terms of the latest standard. And then JEP 3.3.3 is another introduction of a garbage collector. This time it's called the ZGC, or as the Americans like to refer to it, ZGC. And this is an experimental, low latency garbage collector. It's designed to avoid pauses as much as possible in garbage collection because it does garbage collection concurrently with application threads. There were some new APIs in JDK 11, and so I picked a few of those. A couple of things here. So there's the idea of being able to create a null input stream or a null output stream or a null reader or a null writer. So this is the idea that you can say, okay, I want to take all my data and I want to send it to an output where nothing happens to it. Or I want to read precisely 0 bytes from an input stream and that's all I get. And you kind of look at those and go, I've written a lot of code and I've never needed these. So what's the point? And the answer is, well, there's two things. In certain situations where you're using the Streams API, the fact that you're doing a more functional style of programming, there are certain situations where having a null input stream or a null output stream can be quite useful. So it's kind of like /dev/null, if you like. And then there's a new method on optional, is empty, which is the opposite of is present. String has some new methods in JDK 11. So string has come in for some updates. The first of those is blank. I will not say what that does because it's pretty obvious. There is a new method lines, which if you have a multi-line string, then you will get a number of strings representing the lines within that as a stream that you can process. There is also a repeat method that will, funnily enough, repeat the same string a number of times. And then there's strip, strip leading, and strip trailing. And what these do is remove white spaces either at both ends of the string, at the beginning of the string, or at the end of the string. And of course, the observant amongst you will say, hang on, strip, isn't that the same as trim? Because we also have trim already. So why do we need a second one? And the answer is that how the code relates to a white space. So in the case of trim, it uses a simple definition of white space, which is basically space, tab, and new line. In the case of strip, it uses the Unicode definition of white space, which includes a whole bunch of other characters, such as vertical spaces and things like that. But that essentially is the difference. And then my favorite new feature in JDK 11 is the predicate interface gets a new static method called not that takes a predicate. And again, if we look at this, we've got a lambda expression here where we're filtering to say we want to take the lines that are not blank. And so we simply say s is our input string and then not s dot is blank. We can replace that with the new predicate not method and we can say filter predicate dot not, and then we'll use the method reference and we'll say string : is blank. And if we do a static import on the predicate not, we can just do filter not string is blank. So I think that's good because that makes it more readable. You can actually see what's going on more clearly than the code above. Big thing in JDK 11. This kind of happened in JDK 9 already. In JDK 9, they turned off access to the java.se.ee aggregator module. And so when you compiled code or when you ran code, by default, you wouldn't get access to these modules. In JDK 11, they removed them completely. So now you can't even turn them back on, which you could have done in JDK 9 and JDK 10. The modules that are affected are Corba. Anybody using Corba? No. Okay, that's good. That's not a problem. I must admit, I don't think anybody is actually doing any development of new Corba code at the moment. Transaction is related to Corba. Activation is the Beans activation framework. And then there's the JAX-B, Java API for XML binding, to bind between XML and Java objects. And then the one that does seem to catch a few people out is the JAX-WS, Java API for XML web services. And that's the older SOAP WSDL style of web services. Anybody using SOAP-based web services? Oh, lots of people. Okay. Yes, like I said, that does catch a few people out. What you need to do in that case is you need to source the module that you need from somewhere else. Easiest way of doing that is from Maven Central. You just update your POM file, get it from Maven Central, and that's a reasonably easy way of making that work. JDK 12. What did we get there? Well, this is interesting because another new language feature, which is the idea of a switch expression. And this is significant because this is the first what's called preview feature in the OpenJDK. We now have a feature in the Java language which is not defined in the Java language specification. So it's quite a sort of interesting idea. What they wanted to do was say, okay, we may want to change the language, but we don't want to fix the syntax of that feature in the specification because we might want to change it based on feedback. So a preview feature says, okay, let's try it out, let people play around with it, give us some feedback, and then when we're ready, we'll make it a full part of the specification. Now, if you look at the switch statement as we have it at the moment, what you do is essentially it's a multi-line if statement. So you've got if then else type thing. And there's no way of assigning the result of a switch statement to a variable because it doesn't return anything. So it is a statement, not an expression. The syntax of switch tends to be a bit clunky. And the reason for that is because they copied the syntax from C way, way back. And C is a language that's designed for compiler design, operating systems, and things like that. So they prefer the switch statement to work the way that it does. But in application code, you end up with situations where you have to have every case statement separated, and you've got to remember to put a break after the bits you've got in that case statement, otherwise it drops through automatically into the next case, and you get some rather hard to find bugs because, like I know I've forgotten to put break statements in switch statements before, so it's one of those things. And also the scope of local variables can be a little bit less than intuitive. So here's a very good example of how we would typically use a switch expression, switch statement today in older style code. What we're effectively doing is switching on one variable and setting another variable based on that. So we switch on the day of the week, and then what we want to do is assign to number of letters how many letters there are in the name of that day of the week. So in the case of Monday, Friday, and Sunday, it's 6. In the case of Tuesday, it's 7, and so on. Very obvious code. We're all used to the way that works. As I said, we have to remember to put the break statement in and things like that. But it all works in that way. If we use the new switch expression style of doing things, it becomes a lot simpler. So now what we do is we say, okay, the switch is now an expression, which means it returns a value. We assign that once to number of letters, so we don't have to remember to do it in each case block, which could potentially be error prone because we forget to do it someplace or we don't do it in the right way. So now we're only doing it once, which is good. Then for the case statements, they've discovered this incredible technology that's been around for a while called a comma-separated list, which means you don't have to have a separate case statement for each one. You just go Monday, comma, Friday, comma, Sunday. They borrowed some of the syntax from lambda expressions, so they used the arrow, and then the right-hand side of the operator is what is returned from the switch expression. So in the case of Monday, Friday, Sunday, it's 6, Tuesday, it's 7, and so on. And if we need to, we can still throw an exception if we have something we don't like. So this is all good. we can also use a combination of the old style and the new style. So if you really want to, you can do it this way. So you can say case Monday, Friday, Sunday, and you can say break 6. And that's the value that will be returned from the switch expression. And you can see the same thing happens there. And you can go even further with this. You can be even more complex. And you can use code blocks with your case statement. So you could have this situation where you're switching on a level, case 1, and then you can actually define a block of code between the braces where you've got the variable x, you're doing something, and then you break again with x to return x. And interestingly, in this case, they've changed things so in the case of case 2, you can reuse var x. You couldn't have done that in the old style of the switch statement. You can now do it in a switch expression. So there's lots of kind of good stuff there, and I think this is a good feature that's been added. Again, a few JEPs that we've seen, new features that are being added. First of those is the Shenandoah garbage collector. As I said, Alexei Shipalev from Red Hat. This is something he's been working on for quite a while now. It's now been integrated into the OpenJDK, so you can use that. You can test it out. It's, again, targeted at more low latency type of applications, and at the risk of upsetting Alexei, it's targeted at bigger types of heap space. It will run in smaller heap spaces, but it is targeted ideal at using bigger 20 gigabyte plus heap spaces. A couple of updates to the G1 garbage collector. Abortable mixed collections is just the way that things happen in terms of how long it takes a phase of the garbage collector to run. If the system notices that it's actually taking a long time to run a particular phase of the garbage collector, it may actually back out and allow application threads to run again to reduce the pause times that are associated with garbage collection. And returning unused committed memory is basically giving pages of physical memory back to the operating system if they're no longer being used by the heap. So if you run your application and it grows the heap quite big, and then things calm down, you get a smaller active set of or working set of data, then the unused space can be returned to the operating system and used for other applications. JVM constant API, this is related to the dynamic constants that we saw in JDK 11. And what that allows you to do is actually interact with them through a Java API. And then the default CDS archive is the class data sharing archive, so that, as I said, using class data sharing, it's writing out the internal data structures to a file that can be reused. What they've done is create a file that could be reused for the standard class libraries in Java. Streams has a new collector. So there is now the teeing collector. And what this does is it takes two collectors and a by function. And I've drawn a nice diagram here to help you understand what actually happens. The idea is that you take your stream and you divide it into two identical streams. You pass those two streams through the two collectors that you define, take the results of those as the input to the by function. The by function does something and returns a result. Now, when you look at that, you go, okay, I see that. I understand what it does. Give me an example so I really understand what it does. And so what we can do here is we can say, okay, if I want to create if I want to get the average value of some numbers, I can do it this way. So I do stream of, and then I've got a set of numbers. And I pass that into the collect method, and I use the teeing collector, which I've statically imported. You can't see that. And the first collector that I use is summing double. So it sums all of the elements on the input stream. The second collector that I use is counting to tell me how many elements there are on the input stream, because remember, it duplicates both input streams. And then the by function that I use takes the sum and the number of elements and then simply divides one by the other. So that gives me the average of the values on the input. Now, I know I could have done that with a simple call to a collector or a method that will give me the average anyway, but it's the idea of giving an example of how you can use this particular collector. So you could do far more complex things with this. JDK 13, which came out last week, so I have added new things to the presentation, so you're absolutely up to date. So JDK 13 was not a big release in terms of the number of new features. The most significant from a language perspective, which again is a preview feature, is text blocks. So now we have the ability in Java to do multi-line strings. Isn't this great? So the way you do that is you start your string with 3 double quotes, and then everything after those 3 double quotes up to the next 3 double quotes is treated as a string. New lines, escape characters, whatever, you can put that in your string and that will do whatever you want. Now, clearly, if you wanted to put 3 double quotes into your string, then you would need to escape 1 or more of the double quotes. And it doesn't actually, it's quite interesting. It doesn't matter which one you escape. It will work with any of them. And then if we print that out, what we'll actually get is the HTML that we've defined there. Now, the interesting thing here is that the positioning of the 3 double quotes is significant in terms of how the white space is treated. So they have to deal with what they call incidental white space, because what you obviously want to be able to do is to line up your text with the start of the quotes so that you have it indented based on what the code wants to look like. And in this case, what they will do is they will strip out the incidental white space up to the beginning of HTML tag, and then for all lines, it will do the same thing. So as you see, when we print it out, we actually get it lined up on the left-hand margin. The other interesting thing is that if you put the 3 quotes on the line after the HTML closing, should be a closing tag there, then you will actually get an extra blank line. Or you can move the 3 double quotes to the end of that string, and you won't get the extra blank line. Switch expressions. Okay, so I already told you about this. So why am I telling you about it again? Well, this is interesting because in this example, I said that you could combine the use of the old style switch statement syntax with the new switch expression, and you could say case Monday, case Friday, case Sunday, break 6. A lot of people said, well, that's not really very good because you can do a break on a label already. So you can define a label in your code, and you can effectively do a goto or a jump by saying break to that label, and execution will continue from where that label is. If you use a number, that could be a bit confusing because you could have a break with a label and a break with a number. Okay, a label can't start with a number, but you still end up with this slightly confusing overloaded use of break, and it's not ideal. So what they've done is they said, right, this is a preview feature. We will change it in JDK 13. So now they've gone from break to yield. So yield is the word that you use with the number, and you can still do break to a label, so it's less confusing. A few things about longer term JDK futures. Obviously, we're seeing a sort of gradual change. We're seeing little features added quite nicely. What about some bigger things in terms of the future of Java? Well, as I mentioned earlier, there's this idea of Project Valhalla. And Project Valhalla is looking at the way that we store data in Java. Because if you think about Java, you have primitives and you have objects. Objects are great because they give you all those object-oriented things like encapsulation, polymorphism, and inheritance. But the reason for having primitives from the beginning in Java was about performance. Primitives, faster to access, less overhead in terms of object references, and so on. But this then leads us to a problem because sometimes we can't use primitives where we might want to. A good example of that is generic types. If I want to create an array list, I might want to just put ints into that array list, but I can't do that because you can't use int as a type for a generic parameter. In order to do that, you have to use integer, the wrapper class. And that's great because it makes it work. But it's problematic because you have the overhead where every int that you're dealing with has to be auto-boxed into an integer object, which has to be allocated on the heap. Then when you want to get the value out of the array list, you have to unbox that, so you remove the value from it, and then there's the associated garbage collection of the objects you've created. So it's really not an effective way of doing things. So one of the things Project Valhalla is intended to do is to allow you to do an array list of int. So you can effectively do that and you'll be able to store ints rather than integers. The other thing that Project Valhalla is about is value types. Value types is the idea where they say codes like a class, works like a primitive, with the idea that you can treat something like a class, but it is truly, the values in that class are truly final. Now, we already have the final keyword in Java, so you might think, well, okay, if I make a class called foo and I put an int in there and I say it's final, if I set that to 3, then it can't be changed. Sure, you can't change it by saying, I equals 4. That won't work. But if you use reflection, yes, you can. You can change I to whatever you want. And that causes problems if you try to treat things as real final values. So what Valhalla's doing is saying, okay, let's create a type in Java where it works like a class, but codes like a class, but works like a primitive. And you do have truly final values, and you can't change them even with reflection. So you can have methods, you can have fields, implements interfaces, can use encapsulation, can be generic, but it can't be mutated. Absolutely cannot be mutated, and similarly it can't be subclassed because of the effects of that as well. Project Loom is another bigger project that's looking at how to improve massively concurrent applications running on the JVM. And at the moment, the way that Java works is that every thread that you have in your Java application maps to an operating system thread. So there's a one-to-one mapping. And for small numbers of threads, that's fine. It works quite nicely. But if you want to scale up to thousands, tens of thousands, hundreds of thousands of threads, that just doesn't work. What Project Loom is about is saying, okay, let's take the concept of mapping multiple threads to a single process in the operating system and apply that to the JVM level. So we'll have multiple, what they're now calling fibers, which is effectively thread contexts in the Java land, and map it to a single operating system thread. So the operating system thread is shared between multiple fibers. The Java virtual machine is then responsible for scheduling and context switching those fibers onto that thread. And in terms of the work that's being done, they already have the scheduler of the fork join pool, and that seems to work very nicely in terms of the things they need to do on that side. But effectively what needs to be added to Java is continuations. And a continuation is in effect a context for a piece of execution of a thread within Java. So it's the set of values on the registers, it's the stack, and it's what you need to be able to put into a thread in order to execute something. So they're working on that. They're making good progress with this, and I would expect to see this probably within a year, 18 months maybe, we'll start seeing this appear in the JDK itself. Just very briefly mention what we do at Azul, since I'm here. So one of the things that's changed quite a lot recently as well is the fact that the licensing of the Oracle JDK has changed. JDK 11, the Oracle JDK license now says that you can't use it freely in production, which you could have done before. So people are looking at different OpenJDK distributions. We have what we call Zulu Community. This is free. Did I mention it's free? And it's a binary distribution of the OpenJDK. We take the source code, we build it, we generate a binary distribution, then we run the TCK on it, which is about 150,000 tests that say that it does conform to the Java SE specification. We support older versions, so in terms of our free version, we go all the way back to JDK 7, we have 8, 9, 10, 11, 12, and I should have added 13. We have wide platform support, so we've obviously got the 64-bit versions of Windows, Mac, and Linux, but we also have 32-bit versions for both Windows and Linux. If you're still running Windows XP, for example, you can do that. And we have ARM32 and 64-bit versions if you want to run it on your Raspberry Pi. Then, if you want, we can provide you with full commercial support at a very reasonable price. What we do then is we actually do the backporting of bug fixes from the newer version into the older versions, and in that case, we actually go all the way back to JDK 6. So we still support JDK 6 if people want that. We support for a long time, so we're doing 9 years of active support, which is backporting fixes, and 2 years of passive support, which is where we will fix a bug if you find it. Like I say, if you're interested in that, you can either talk to me later or look at our website. So just to summarize, Java continues to evolve, and we've seen this big change from multi-year releases to 6-month releases. It seems to be working. Certainly the process involved in the JCP, getting the Java SE specification through. I represent Azul on the Java SE expert group for JDK 9, 10, 11, 12, 13, and now 14. And that does seem to be working. We're actually getting the specifications done in time, and everything's working in that way. There are lots of ideas for improvements to Java, both small things and big things, value types, fibers, syntax improvements, all sorts of things like that. So there's lots of things still going on in Java, and expect to see more in the future. And with that, I have just about finished. So thank you very much. Dankeschön.